All right, today we are jumping into a really big topic for anyone building with LLMs, context compression. We're going to break down how you can get way more signal into your RAG systems and do it for less cost. Let's get into it. So if you're building a RAG app, I bet this question feels familiar, right? You've done all the heavy lifting, you've retrieved all these great documents, and now you're just trying to cram it all into the model. But you keep hitting these walls. It's too slow, it costs too much, or it just plain doesn't fit. Yeah, this is what we call the context overflow problem. And it feels a little backwards, doesn't it? You'd think more context equals a better answer. But as we're about to find out when it comes to feeding these models, sometimes less is actually more. Okay, so let's get specific. Why exactly is your context becoming such a bottleneck? Well, first, you've got the hard limits of the context window itself. You can only fit so much in there. Second, and this one hurts, the cost. Every single token costs you money. More tokens, bigger bill. Simple as that. Third, you've got noise. Not all the info you retrieve is golden. You end up with repetitive stuff, maybe some irrelevant sentences, and all that just dilutes the good stuff and can actually confuse the model. And finally, speed. The more tokens the model has to chew on, the slower it generates a response. And a slow app means unhappy users. So, we've laid out the problem. Now for the fun part, the solutions. And look, there's no single magic bullet here. Instead, think of it like a builder's toolkit. Let's open it up and check out the 4 main tools you've got for compressing context. First up, we've got the extractive method. The best way to think about this one is like a surgical scalpel. It goes through your documents and, based on what's relevant to the query, it just precisely cuts out and keeps the most important sentences. The key thing to remember is it's not writing anything new, it's just selecting the best bits of what's already there. All right, tool number 2 is the abstractive method. You can call this the summarizer. Now, unlike the scalpel, this one doesn't just select text, it actually creates new text. It uses a large language model to read everything and then write a whole new, super condensed summary. It's awesome for just capturing the main idea, the real gist of the information, in a tiny package. Okay, now for something a little more advanced. This is LLM Lingua, or the token trimmer. This is a really cool, specialized model built for just one thing: making prompts smaller, and it gets down to the most nitty-gritty level possible, the individual token. It trims out anything that's not absolutely critical, which lets you get some pretty wild compression ratios without losing as much quality as you'd think. And our last tool in the kit is selective quoting. I like to call this one the evidence gatherer. This approach is fantastic when you need to know where the answer came from. Instead of a broad summary, it goes through each document chunk and yanks out the single most relevant 1 or 2 sentence quote that hits the query nail on the head. So what you're left with is a bunch of powerful, directly cited pieces of evidence. So there you have it, 4 really great tools. But which one do you pick? Well, just like any good builder knows, choosing the right tool for the job is an art form, and it all boils down to understanding the trade-offs. But before we dive into the nitty-gritty of those trade-offs, let's just ground ourselves in the main goal here. We're not just trying to make things smaller for the sake of it. It's a balancing act, right? We have to shrink the context, sure, but we have to protect the key information inside. That's the guiding principle for everything that follows. And this table here, this really puts some numbers to that balancing act. You can see the relationship pretty clearly. If you're just doing a light compression, say 10 to 20%, that's perfect for just cleaning up some redundant sentences. You'll have minimal quality loss. Need to just barely squeeze something into the context window? Pushing to 30 or 50% is probably a safe bet. But once you start aiming for serious cost savings, getting into that 50 to 70% range, you have to be okay with a medium risk of losing something important. And going beyond that, well, that's high-risk territory. The other huge trade-off, of course, is speed. Latency matters a lot. On the one hand, you have your speed daemon, a simple extractive method. It's blazing fast. But on the other side of the spectrum, anything that needs to make another call to an LLM, like our abstractive summarizer or the selective quoting tool, is going to be slower. You're adding a whole other network hop and inference step. LML Lingua kind of sits in the middle. And, for any app that a real person is using, every single millisecond counts. So how do you know when to actually pull the trigger and use compression? Well, here are the big green flags. The most obvious one: your context is just too big for the model's window. You literally have no choice. Another big one: your API bills are getting scary. If you're worried about costs, it's time. Also, if you look at your retrieved documents and they're just messy, full of repetitive junk, compression can actually make your answers better. And of course, if speed is a problem, this is one of the main levers you can pull.
But, and this is important, compression is not always the answer. Here are the red flags, the times you should probably skip it. First, if your context fits just fine, don't over-engineer it. Don't add complexity you don't need. Second, think about your domain. If you're working with something like legal contracts, where every single comma matters, the risk of dropping one critical detail is just too high. And finally, if your app absolutely cannot handle any extra latency or any dip in quality, well, then you have your answer. Steer clear.
Okay, so knowing the tools and the trade-offs is step one, but really mastering them, that's where you go from just building something to building something great. So let's look at how to put these strategies to work in a really smart way. Check this out. This is a super clever pattern called adaptive compression. The idea is, instead of just blindly compressing everything, you build a little bit of logic. Step one, you measure. Is your context size okay? Let's say, is it under 70% of the limit? If yes, great, do nothing, no compression needed. But what if it's just a little bit over? Then you use a fast, lightweight tool like the extractive method to just trim the edges. And only if it's a huge overflow, that's when you bring out the big guns, like the slower but more powerful abstractive summarizer. See how that works? You only pay the performance penalty when you absolutely have to. Oh, and here's a pro tip that'll save you so much time and money. Cache your results. Seriously. If you get the exact same query and you retrieve the exact same documents, there is zero reason to recompress everything. Just store the compressed version the first time and then pull it from your cache. It's such a simple thing, but it makes your whole system way, way more efficient. All right, so we've covered the why, the what, and the how of context compression. Let's wrap it all up and tackle that one final, all-important question. So, after all that, what's the best compression tool? The answer is there isn't one. The best tool is the one that's right for your project. It all comes down to finding your unique balance point between three things: cost, quality, and speed. How much can you spend? How fast does it need to be? And how perfect does the answer have to be? Your perfect strategy is the one that nails that balance for you.
And that really brings us right to the edge of where this whole field is going. You know, we're getting pretty good at squishing text down to get more signal into these models. But the next frontier, it's already here. What happens when your RAG system doesn't just need to read text, but needs to understand images, or data in a table, or info that's locked inside a chart? Compressing that kind of context? Well, that's a whole new ballgame. Thanks for tuning in.